Eminent presenter Dr. Deepak Tripathi is Chief Mechanical Engineer, Head of Rolling Stock and Projects, Konkan Railway Corporation Limited, KRCL. Has 3 decades of experience in the railway industry in areas of rolling stock, manufacturing, operations and maintenance, product and vendor development, quality assurance, infrastructure and technology, project management and business development, including international business. A keen learner, practitioner and trainer with doctoral qualifications specializing in operations, quality and lean management, he has made significant contributions through authored books, research papers, international conferences, workshops, training programs to promote lean quality and industry 4.0 practices. He has been promoting transformation of railway industry globally through lean and industry 4.0 practices and steered several such projects on rolling stock operation and maintenance, smart workshops, IoT-based predictive maintenance solution for smart yacht. He is recipient of awards both at national and international levels, such as Minister of Railways Award for Outstanding Services, Best Innovative Idea of the Year Award by Minister of Railways for a patented wayside rolling stock condition monitoring system, nomination for Eminent Engineer Award by Engineering Council of India, Outstanding Author Award by Emerald Publications UK, and Lal Bahadur Shastri Award for the book Smart Lean Management. And a very warm welcome to you, sir, and over to you for your presentation.
I welcome to all the delegates who are connected with me for this session. And I also thank the organizers for giving me this opportunity to share my views and the work that we are doing in the area of Industry 4.0 and digital application in railway systems. As we all know, now we are into the fourth industrial revolution. It all started with first industrial revolution powered by the steam engine, and which really started the railway industry, which later was transformed into a major mode of transportation with the induction of electricity in the second industrial revolution. And the third industrial revolution, which was driven by the PLCs, computerization, and information technology, which resulted into the modernization of the railways, and such as the modern signaling systems, induction of enterprise resource planning into the railways, and so on and so forth. And the fourth industrial revolution, which is now enabled by the cyber physical system, as we say, gives a real opportunity for the railway industry to lead the logistics space. And at the same time, if we don't act now, we may lag behind because our competitors are also catching up. So that's what the industrial 4.0, that is what is important for all of us who are part of the railway systems. I would define industry 4.0 from 4 perspectives. It's about a new paradigm in industrial value creation, which is enabled by the advancement in operations, information and communication technology. It is built on cyber physical system, which actually enables the communication and interface between products to machine, machine to machine, machine to people, and people to people. It is driven by 4 disruptions. These are the rise in the variety and the volume of data, the computational power and the connectivity, the advanced analytics and business intelligence capabilities that we have now, and the new forms of human-machine interface in terms of augmented reality, virtual reality, and so forth. And the real improvement that has come up now with regard to transferring the digital instructions to the physical world, and which we use as robot in form of robotics and 3D printings. And it is actually enabled with the emerging technologies in the area of operations, information and communications, such as IoT, data analytics, cloud computing, etc. Some of the technologies and applications that are relevant to the railways, and we find applications globally. We can say Internet of Things, RFID, big data analytics, machine learning, artificial intelligence, business intelligence, cloud computing, and applications such as human-machine interface, virtual reality, augmented reality, image processing, digital twins, blockchains, etc. Industry 4.0 is a very generic thing which has applicability into almost all types of industries, and they have been offshoots to especially cater to the different verticals, different industries, different segments and domains. And as such, now we also hear of the rail 4.0, which is offshoot of industry 4.0 for application of the digital industry 4.0 technology into the railways. And rail 4.0 has find its applications into different domains of the railway industry, which are customer interface, operation and maintenance, infrastructure and asset management, rolling stock, construction and project management, people management. So we can find globally, if you see cases of the implementation of Industry 4.0 and the digital into these domains of the railways industry. And we can find a lot of scope, as we see, of Rail 4.0 in building capabilities for the future of railways, such as automated train operations, logistics on demand, the optimization of use of energy and resources, and environmental and social sustainability, intelligent trains, smart stations, and the improving asset reliability, health of the assets, both rolling stock and the fixed assets, and also building a low-cost railways. So the scope for the improvement in the railways is this tremendous, immense scope of we have with Rail 4.0. We can see some of the advantages that we have. We can build connected railways, which can provide reliable and better connectivity, and can provide safe and efficient and attractive railways, both for the customers and the people and the employees. And then we have better customer experience through digitalization of the railway, and which can also offer better value-added services to the customers. Then the use of digital and Industry 4.0 can also help in increased capacity of the railways, such as use of IoT, automated train operation, AI-enabled predictive maintenance. These increase capacity, efficiency, and performance. And then in turn, we build a competitive railways, and both in terms of the improving cost, quality, and delivery performance. Now coming to the initiative that we have been taking in this area. So I am talking about the three initiatives that we have been taking under Rail 4.0. These are smart workshops, smart yards, and smart track maintenance. Smart workshops actually is an Industry 4.0 enabled rolling stock workshop, which is built through automated lines, robotics, IoT, SCADA, etc. Then we have smart yard, which is AI-enabled rolling stock predictive maintenance systems, such as ATS that we have developed. Smart track maintenance, we have the track machine maintenance management system and AI-enabled track inspection system, RTMAS. So these are some of the initiatives that we have been taking into different domains of the Rail 4.0. The smart yard and smart workshop, they are part of the overall maintenance ecosystem, smart maintenance ecosystem, where we have smart rolling stock, which can have capabilities such as inbuilt RFID tags for wagon identification and storage of data, and it can have onboard condition monitoring systems and which continuously monitor the condition of the rolling stock. And with this, we have smart yards, which include a network of wayside equipments provided on the main line and also on the yards. Some of the smart yard equipment that are seen in Indian railways and are used in India are hot box detectors. ATS we have built in the Konkan railways, and then we have OMRS, we have Wild, we have wheel condition profile monitoring system WCMS, and then we have vision machines. In our ATS also we have a vision based under gear condition and vision processing system. So based on the smart yard and smart wagon, we maintain, and then we have a smart workshop that actually take inputs from the smart wagon and smart yards, and accordingly undertakes the activity overhauling of the rolling stock. And it also, whatever work is done in the overhauling is also fed into the system, the ecosystem, and then that is used during operation and maintenance in the field. So that's what the schematic of a smart rolling stock, where we have train, then we have RFID for the individual wagons, then individual wagon components like bogies and wheels. They have individual IDs also connected with the RFID of the wagon. And then we have various condition monitoring systems inbuilt. This is a typical schematic of a smart wagon, where we can see all these things built in. We have developed automated train examination system as part of this entire scheme. It has capabilities to measure the condition of the wheels and condition of the axis of the rolling stock, and it also has the video-based systems to monitor the condition of the undergear, such as hanging parts, broken parts, and missing parts. So this system captures the information, the data from the field, from the track side or in the yard, on main line, or in the railway yards, and then it does. This is a typical a site, the photograph of a site. We have installed ATS, and we can see different components of the system laid on the track side. Then we have a very powerful external notification system as part of ATS, where we can see the various parameters of the wheels, axles, and the undergear. And we have videography of the undergear. We have the information in the form of graphs. So we can the rolling stock, by whether it is wagon or coach, we can find the entire information. It can be made available through ANS. And then we have built in the data analytics system, where we can do the trend monitoring of various parameters, which can be used for predictive maintenance. And we have also done work on image processing, where we have the videograph, we have the screenshots, where we can do a bit of the image processing to actually find the defects on the undergear. So that's what the ENS of ATS is. And this is the schematic where you can see that the trackside data is transferred to the control panel, then through router it goes to the control room, and then it is relayed to the cloud servers. And we also have mobile app where we can actually see on a smartphone the entire information, which can be useful for the technical staff on the field and also the managerial staff in the offices. Also working along with CDAC to actually now built in a AI or artificial intelligence based vision processing system, where we can actually now also able to see the defects, the visual the defects such as missing, broken, and hanging parts, and alerts can be raised and relayed to the concerned users. So this is what the ATS is all about. And then ATS also can be part of the overall smart yard the system, or it can also be upgraded and with addition of different modules. So we have two options: either ATS becomes a part of the smart yard system, or ATS can be the various module can be built in and added to the ATS to make it just real smart yard equipment. There are few we have done installation, almost 10 installation now we have in the railways. Another system that we have built to improve the track maintenance. This is called the track machine maintenance system. It is a web portal and Android application based system which is used to monitor and maintain the track machines, rail maintenance vehicles, and utility vehicles. It has the features such as GPS for tracking the movement of the machines, and IoT enabled the parameters from the machines. So this entire system is able to capture the machine history, movement tracking. It helps in operation and preventive maintenance, and also the inventory management. So this is a schematic of the track machines management system, where you can see the system can be is used by the machine operators to feed in data, and some data is also fed directly with the sensors, the IoT devices, and through GPS we are able to track the movement of the machines to actually see how much the machine has moved. It can also be able to give us the productivity performance of the machines. Then we have the remote location supervisors, which does the monitors the daily progress, and also feeds information from his panel, and also able to monitor the performance of the machine. Then we have another layer of monitoring at the level of executives and supervisors, and we can generate various these reports, MIS reports, performance reports in various formats. So this system currently we have developed in the Konkan railways, and we have covered almost 5-6 types of machines, and in total there are around 12 machines have been covered under this system. This is the screenshot of the Android application, which actually you can see on your mobile. The user able to see you can see the dashboard on the mobile on the left hand side. Then we have the screen for for feeding the inputs, the data by the operators, and on the right side you can see the performance, the various parameter we can monitor. So this has the Android application which used on the smartphones. Then we also have web portal screenshot which can be seen on the computers and laptops. And this is a typical dashboard where we have different features, right from feeding information to generating reports, various form of reports. And this is how can we track using the GPS the movement of the machines. We are also working now on a very it's actually on a POC basis now. Currently we are working. We call it Rail Track Monitoring and Alert System, RTMAS. It's an artificial intelligence machine learning enabled image processing solution, which can be used to detect unusuals on railway tracks, such as boulder fall, soil slip, flooding, water logging, some interruptions or interventions on the track, movement of cattle animals, sabotage, etc. RTMAS has two units. One is the railway unit, other is the server side software, and it helps in generating cautions and alerts without any human intervention, and it in turn helps us improve safety and response times, and also the cost of track monitoring. It's a typical schematic of a RTMAS system where we can see on the left side we can see the rail side unit, which we call rail view, and it is connected with the station through through wires, through cables, and also its system has the cloud server and a server located at the central control room. The system is currently under trial, and we hope to get some success in this field. So our railway unit is installed on track sides. It has multiple cameras and image processing computers, and it is solar and battery powered. Both options we have. We have a real-time machine vision system, high processing engine, and then on server side we have cloud-based server solution. We have AI ML based systems for object detection and identifications. We have features such as automatic alert generation, report generation, and we also have option for the Android-based client application. So here also we'll have both Android-based application and web-based application. These are some of the photographs you can see which we have been taken during trial. On the left side, we have RTMAS object detection trial. So we are able to identify the objects which are actually obstructing the track. And on the right side, you can see the photograph of a boulder fall, which we should be able to detect with the system in case such obstruction comes on the track. So that is what I wanted to share with you. The entire the concept of the digital and industry 4.0, how it is relevant to the railways, where we can find its application in the railways, and also some of the initiatives that we have taken. I hope that it has generated some interest, and in case any queries, I have also listed down here my email address, so I can be contacted in case of any further details are required. Thank you.